Hello, everyone. Happy Wednesday. Hope you all are having a great couple days since I last talked to you. Today, we're moving on to section 8.2, which is actually a lot of geometry involved here. We're going to talk a little bit about floor plans. Now, I think the name of this section is a little misleading, reading a floor plan. We're not actually going to read a floor plan. We're going to more do geometry questions that would go along with answering some questions about the layout of different rooms in our house. Okay, so the first thing is we are going to do some, like I said, with geometry and find the area. And the only questions we're going to do today involve the area of a rectangle and the area of a circle. Okay, so as a quick recap, to find the area of a rectangle, okay, you could write it one of two ways. You could write base times height, or a lot of times we'll just say length times width. Okay, and then for area of a circle, area is going to equal pi times radius squared. Okay, again, now the radius is the length that goes from the center of the circle to the circle itself. So as a quick little demonstration here, let's say I was to draw a circle and I want you to identify the radius. Again, that's the length of the line that goes from the center, that's about the center, to the outside of the circle. Okay, and again, that would be known as the radius. If we're to go all the way across, that's known as the diameter. Okay, but before we get into those questions, we're actually going to do some that involve some proportions. As a reminder, a proportion is when we set two fractions equal to one another. And we solve a proportion by using cross multiplication. Okay, so here Jerry is using the floor plans for his new home to help him purchase base molding for the place where the walls meet the floor. The plans are drawn using a scale of 1/4 inch represents 1 foot. He measures the walls on the floor plan with a ruler and finds that they total 23.5 inches. So if molding costs $2.10 per foot, how much will Jerry spend on molding? Okay, so our first job here is to figure out, exactly how much molding that we need. Because we see how much, what length we have on the floor plan, right? It's 23.5 inches there. We got to figure out, what does 23.5 inches on our plan correspond to in real life? So we're going to do that by actually going ahead and setting up a proportion. Okay, so the first fraction we're going to write down is the one that represents our scale. So I'm going to write down as, all right, well, we know 0 or 1/4 inch, which I'm going to write as a decimal, which is 0.25 inches. Okay, and we know that represents 1 foot in real life. So we say 0.25 inches to 1 foot. Okay, now we're going to set that equal to another fraction, and we're going to set it the same way using the information that we know. Because we have here that's 23.5 inches on the plan. So since that's our floor plan length, that has to go in the same position as the floor plan length went in our first fraction. So that's the top part, right? That's 0.25 inches. So I have to put 23.5 inches up top in my second fraction. And the bottom, we're going to show how much that represents in real life, which we don't know. What do we use to represent length we don't know in an equation? A variable. So we'll put x down here. So we say, all right, 0.25 inches to 1 foot is the same as 23.5 inches to how many feet? We want to see what that would equal. Now we're going to solve this by cross multiplying. So cross multiplying goes diagonally across our equation. So I'm going to first multiply 0.25 times x, which is just 0.25x. And that's going to equal 23.5 times 1, which is just 23.5. Okay, so now we want to solve this equation. So I'm going to get x by itself. So I'm going to divide both sides by 0.25. Okay, so 23.5 divided by 0.25 is going to give us 94. So that means that since our floor plan is 23.5 inches, that would represent 94 feet in real life. So we have 94 feet of base molding that we need to buy. Okay, we're not done yet because we're trying to find the cost if we have to spend $2.10 per foot. So from here, let's take the number of feet we have and multiply it by the price per foot. So now we're going to take that 94 feet. We're going to multiply it by $2.10 per foot to get a total cost here of $197.40. Okay. Next example. So the length of a room is 17 feet. When using 1/4 inch to 1 foot scale, what is the length of the room on a floor plan? So this is kind of the opposite now, because we know how much we have in real life. We want to figure out what that would represent on the floor plan. So we're going to start the same way we did the last one by setting up our first fraction using the scale of our floor plan. So we're going to say 0.25 inches or 1/4 inch represents 1 foot. Okay. Now, since we know how many feet we have, that number has to go on the bottom. Right? Because see how that kind of corresponds, right? Real life distance on the bottom, real life distance on the bottom. And we don't know what that would be on the floor plan. But we're going to solve this the same way now that we have our proportion set up. We're going to go ahead and cross multiply. So we're going to multiply 0.25 by 17, and that gives me 4.25. And then 1 times x is just x. Okay, and label it. We're looking for inches, so it'd be 4.25 inches on our floor plan. Easy as that. All right, let's get into some area questions. So Gabriella plans to carpet her living room, except for the quarter circle shown in the corner. That area will be a wood floor where she will put her piano. The radius of the quarter circle is 8 feet. If carpeting costs $9.55 per square foot, what is the cost of the carpeting that she will use in her living room? All right, so the first big thing here is, look at this diagram. So basically, I want to carpet this entire rectangle besides this quarter circle. So really what we want to do, we want to find the area of the living room, and we're going to subtract from that quarter circle. Okay? Because basically I find the whole thing, then we're going to take away what we don't want to carpet. All right, so first of all, let's think about this. So how do we find the area of the living room? Well, a living room is a rectangle, and we talked before that the area of a rectangle is length times width. So that would just be, and it kind of tells us here, is 25 feet by 16 feet. So it would just be 25 times 16. Because it's saying that the length is 25 feet and the width is 16. Okay? Now we're going to subtract from that our quarter circle. So to find the area of a whole circle, it would be pi r squared. But we want to quarter that, so we can either divide that by 4 or multiply it by 1/4. I'm going to stick with multiplying by 1/4. So I'm going to say my circle is 1/4 times pi times r squared. Well, what is our radius? And it says right here, the radius of the quarter circle is 8 feet, meaning that this length right here, from what would be the center to the outside, represents 8 feet. So it'd be 1/4 times pi times 8 squared. Okay, so 25 times 16, let's simplify that. That would be 400. So that is what the area of the rectangle is. And we're going to subtract from that 1/4 times, if you plug in your calculator, pi times 8 squared, well, 8 squared is 64. And 64 times pi would be 201.06. Okay? And if you have your phone calculator on you, there is a pi button there that you can use. If not, you can always just use 3.14 to represent pi. Okay? And then 1/4 times our area of our circle is going to give us 50.27. So the area of the rectangle is 400. The area of the quarter circle is 50.27. So our last step now is to subtract those two things. So we get a total area here of 349.73. And since it's an area, we label it as feet squared or square feet. So now we got to figure out what the cost of the carpeting would be. So we know how many square feet of area we have. So let's take that number and multiply it by the cost per square foot. Okay, so I'm going to go ahead now and take my area, so 349.73, and multiply it by 955 per square foot, and my total cost is going to be $3,339.96. There we go. All right, next example. So Alexis is retiling the floor in her kitchen. There's an island in the middle of the kitchen that does not need tiling underneath. So how many square feet of tiles does she need? All right, so kind of the same idea. We're going to find the area of this bigger rectangle and subtract away the area of that island because we don't need to tile that. So it's going to be the bigger rectangle minus the smaller rectangle. Again, area of rectangles is always length times width. So we're going to go ahead and multiply 25 times 10 together because that would be the area of the bigger rectangle. And we're going to subtract from that the smaller one, which is 6 times 3. Okay, so 25 times 10 is 250. And then 6 times 3 is 18. So then 250 minus 18 will give us 232 feet squared. All right. Now we're going to do a little bit of volume. So volume is a similar idea to area, except it's three-dimensional. So if area is looking at the amount of two-dimensional space in a shape, volume is the three-dimensional space, right? So we're looking at maybe how much water can fit in a pool, right? That would be volume. Or the amount of air in a room would be volume. And that's kind of what we're going to do here. So to find the volume of a room, which we're looking at, that's also known as a prism. Okay. So for volume of our prism here, a rectangular prism, it would be length times width times height. And we look at this example, right? It tells us it's 14 by 16, so that's the length and the width. When it says with an 8-foot ceiling, that means the ceiling is 8 feet off the ground. So that's the height of our room, okay? So to find the volume here, all we gotta do is say, all right, well, length is 14 feet, width is 16 feet, and our height is 8 feet. So 14 times 16 times 8 would give me 1,792. And again, since it's three-dimensional space, we're going to label it as feet cubed or cubic feet. All right, so why are we talking about volume? Well, the last thing we have to do is do this thing called the British thermal unit, okay? Now, a BTU, or a British thermal unit, is what we use to represent how efficient or how powerful an air conditioner is. And if you go shopping for them, you'll see them rated on how many BTUs they have. Okay, there's a formula to figure out what type of air conditioner you need based on the type of room you have. So the formula here is WHILE divided by 60. So those letters all represent different characteristics of your room. Okay, so W, H, and L represents the width, the height, and the length. Now think about that. If I think about those three variables, width, height, and length, okay, that really is our volume. So really it's kind of like the volume of our room, and then we take into consideration how well insulated that room is. Because if it's better insulated, we might not need as powerful of an air conditioner. If you think about it, if your room isn't well insulated, right, it's not going to be able to hold on to that coolness or the air conditioned air. Exposure means how much sunlight does it get, right? So how quickly would it warm up during the day from sunlight? So WHL is volume, and that will be given to you in the problem. And then I, insulation, and E, exposure, are numbers we use based on how that room works. So if it's well insulated, we use an I value of 10. Poorly insulated, we use an I value of 18. Exposure, you see here different numbers associated with which way that room faces. So you will not that you would ever need to memorize this chart, But for using or for doing out your lesson check later, okay, you will need these examples. I'm not going to give it to you. So it might be a good idea that you take a picture of this slide or jot down your notebook. So you could pause this video, take a picture, put in your notebook. Okay, then once you're good, we'll move on and I'll show you an example. Okay, so let's do one out. So Mike's bedroom measures 16 feet by 14 feet and has a 9-foot ceiling. It is well insulated and on the west side of his house. So how large of an air conditioner should he purchase? Okay, again, our formula here is while divided by 60, or WHILE divided by 60. Okay, or volume times insulation times exposure divided by 60. Okay, so I'm going to go ahead and say, all right, well, let's plug in these values. What is the width of his room? Well, it doesn't matter which one's width, which one's length. It's 16 by 14. So I'm going to say 16, okay, times height, which is how tall the room is, and it has a 9-foot ceiling. So that would be 9. So 16 times 9 times I is the insulation. All right, so it's well insulated. So if I look back at our formula, if a room is well insulated, we should use an I value of 10. Okay, so I'm going to use an I value of 10 here. L is the length, which is 14. And then E for exposure is on the west side of the house. All right, so west side means we want to use an E value of 20. I'm going to go ahead and plug in 20 for our exposure. I'm going to take all that and divide it all by 60. Okay, so plug our calculator, 16 times 9 times 10 times 14 times 20, hit enter, divide that by 60, and that gives us a BTU of 6,720 BTUs. All right. So guys, that's our lesson for today. So go ahead now and please complete the lesson check, and I will talk to you all tomorrow. All right, have a good one.